first of all, I would like to explain that what we are doing, it's not exactly modeling. So sorry, because our understanding, what do we mean by fire scenario? We are referring to contextual factors of fire regime. We are referring to areas of homogeneous fire spread patterns. Our concept of fire scenario is the concept that was built up in Fire Paradox project and was already published in final report of this project by EFI. And then we have also published an article in Forest, and we have been talking and discussing about this concept and ideas with John Keeley and Alexandra Siffard in the UCLA for 2 years. But it's not exactly the concept or the meaning of fire scenarios from modeling. The purpose of our research, what we are working on, is to reconstruct the fire scenarios with that meaning in the Central Mountains Range region in Spain from a historical point of view. So we are not looking to the future, but to the present and to the past. We are starting from the fire scenarios at the regional scale methodology for defining the fire scenarios at the local scale, and then with the final aim to reconstruct the historical evolution of fire scenarios back. And what we are going to show in this presentation is that the methodology that we defined in all these previous projects is working and is reproducible and is useful for other objectives, for other contexts, for other places. Because when we built up this methodology, we applied it to the Mallorca Island, which is a place in the Mediterranean region from the fire risk point of view of ministry. And now we are working in the inner regions of Spain, the Central Mountains Range region, quite different, with a space shared by different regions, political regions, autonomous communities, several provinces, different landscapes, very complex area where we are confronting the two concepts or ideas that are at the basis of our theory. These two concepts or ideas are the fire generation model, defined by Marc Castaneau team and in frame of this European project, and then the concept of landscape character assessment, which is related to geography and to this complex discipline of sociospatial sciences. So from these two concepts, we have already worked in the whole Spain, and we have obtained 57 scenarios at the national scale, but we are not talking about that because those scenarios are the result of this concepts, theory, and methodology, but with different objectives, quite different objectives to the scenarios at the regional scale. The regional scale, we have also worked for the example of Mallorca Island. We obtained at that moment 12 scenarios. So the aim now is to explain how we work for obtaining that, and is that methodology useful, reproducible, and has an application for other objectives too, and at what extent that methodology is useful for being integrated in models for the future.
Well, in the left we have the map according to our methodology, and in the right we have the homogeneous fire regime zones, indicating also the natural fire rotation. It's a contribution of Pau Costa Foundation to plan General contra Incendios Forestales to Balearic Island. There are units, special units defined according to the same local and winds regimes, same physiography, similar land use, land cover, and with the same fire type. You can see there is a some correlation in shapes, boundaries from the two methodologies. We can explain our methodology. In the first stage, it's a problem of regionalization. And when you analyze, you make a regional units. You need a land analysis unit, an aerial analysis unit. We select watersheds. Watersheds, well, they can be nested one in another. It is very useful to work at different spatial scales, and you need some variables, some attributes to these units. We select at this point of the methodology two different kinds of variables: structural ones like forest area, agricultural area, and two dynamic attributes: agricultural abandonment and forest progression, to confront and to make this first stage.
Thank you. As Professor Galiana has already mentioned, we have used watersheds as our analysis units. In a particular case, for our case of studies, what we have done is develop these watersheds using GIS hydrological capabilities and the digital elevation models. And once we have defined these units, and we also have all the data for the variables that we can see over here: forest land cover, agricultural land cover, agricultural abandonment, and progressive forest dynamics. What we do, and the basis of our methodology, is to calculate for each watershed what is the proportion of the area that is covered by each of these variables, right? So we end up with a table of several thousands of watersheds, and each of them is characterized by a percentage of coverage of one of the, by each of one of these variables. This is a rather long process to do manually, so what we have done is produce a Python script to automate the process, so we can make it easier to calculate for several regions. And once we have all this data calculated, what we do is classify all these watersheds based on these variables through a k-means cluster analysis. So what we end up with is a table of watersheds that have a specific type of territorial dynamic that is assigned to it based on this cluster analysis that is done with these initial shelters as an example. And the final product of this would be a map that Professor Galiana will explain in further detail.
Okay, this is the first result. It's the structural and dynamics map, and well, we can define different kind of areas: agricultural ones, stable agricultural in purple in the north. There are open fields. In the south, very well managed forest park, the ESAs of green oak or cork oak, surrounded by violet units that are defined by a strong agricultural abandonment process. On the other hand, we have forest stable forest areas in light green, surrounded by dark green areas that confront forest progression in shrublands or grasslands, and different degrees of different gradation in the agroforestal patchwork that conform the main Sistema Central mountain range. The stage one is devoted to define the third generation areas, defined by a forest progression in the former forest areas. At this point, we confront the main forest species because it's a key argument to express the high level of ecological variation of mountain range, and to confront with the forest management, the variation in every landscape unit. The sample of the inventario forestal is very reduced, and we can't work at watershed level, and we work at landscape units. It's very nice to correlate forest species, like for example Pinus sylvestris in Sierra Guadarrama, very well managed, or the forest parks in the south, also very well managed, against very poorly areas managed of Pinus pinaster, for example, at this moment in Macizo de Gredos. The stage 3 is devoted to the fourth fire generation, and at this point we confront the urban areas, villages, with the confluence with urban areas, villages, with dense forest areas defined with more than 30% of forest cover. Well, at this point emerge the problems, the progression of wildland-urban interface in the metropolitan area of Madrid, in the region of Madrid. You can say Madrid at the southeast of the region, very near Sistema Central, and all the metropolitan area is the northwest of the metropolitan area is in the Sistema Central, and this drives to a strong problem of interfaces. The more problem is in the southwest, because well, there are a confluence of dense forest areas, Pinus, Pinea stands very poorly managed, and urban areas that confront the fourth generation model. Well, as Cristina Montiel has said before at the beginning, this is research to reconstruct fire regimes in the long-term history. Then, in the methodology, we analyze and we confront the different patterns of occurrence of fires from 15th century to until today. In the left, we have the results of wildfire analysis according to our historic database. There are a fire database from 15th century. The more ancient record it's at 1497 until the statistical period that begins in Spain, as we already said, knows at 1968. And in the right we have the recent occurrence. At this point is analysis from 1998 until today, to confront patterns and the variation of patterns in the long-term history until today. Well, we arrive finally to the results. We return to the Mallorca island map that express a spatial differentiation of units according to wildfire generations. Every area has been put in a generation, first, second, or third, and also consider the wildland-urban interface problem to assign the fourth generation area. We arrived to this map that we have seen before. For every regional scenario, we make the definition, a delimitation of boundaries, and a characterization in terms of dynamics, structure, and can recognize similar patterns, homogeneous patterns of fire spread and fire ignitions. There is Badia de Palma as an example of regional fire scenarios. It's a high urbanized area in the island with a forest progression linked to the agricultural abandonment that make the progression, the interface, a high problem to the management of the forest in this town. Well, to arrive to conclusion, well, regional fire scenarios, it's a contribution to forest management from social science. It's a contribution to wildfire management to social science using a landscape approach. Why a landscape approach? Well, a landscape approach allows us to work at different scales, different spatial and temporal scale. Landscape patterns show us a long-term history variation according to cultural features, physical features, according to the role played by fire, by occurrences, by use of fire. Landscape approach, it's a tool for management socio-ecological systems because a landscape approach enhanced human practices, cultural roles that are absolutely crucial to explain the dynamics of the territorial dynamics and the fire dynamics and fire regime dynamics in the territory. In short, it's a step to coexist with fire, enhancing and enlightening the understanding of societal discourses and risk constructs at the landscape level. Thank you very much.